Hello and welcome. This is the solution to the problem of the day posted on 7/27. Okay, the problem was given the metric tensor components, here's the three, derive the curl of vector A in spherical coordinates using this equation. Okay, so here is the determinant of the metric tensor. Here's the square root of the determinant. And I'm going to use ones, twos, and threes for r equal 1, theta equal 2, phi equal 3. I think it makes it easier because of the pattern we like here. All right, so here's our pattern. Here's the generalized equation. Okay, so we're going to start with E1. So let's see if I can get all this on the screen. So if we start at 1, we go 1, 2, 3. So we got E 1, 2, 3. And when this is AK, so it's 3, and the derivative is with respect to 2. Then we go over here and we go 1, 3, 2, 1, 3, 2, and then the 2 goes here and the 3 goes there. Okay, now we know that that's a positive and that's a negative. So we got the 1 for E1. Let's do the same thing for E2. All right, so we start at 2. We go 2, 3, 1, 2, 3, 1. This becomes the 1. This becomes the 3. Then we start at 2. We go 2, 1, 3, 2, 1, 3. Here's the 3 and here's the 1. And we know that's positive and that's negative. Last one. Start at E3. So we start at 3. 3, 1, 2. 3, 1, 2. The 2 goes there. The 1 goes there. Start at 3. We go 3, 2, 1. 3, 2, 1. 1, 2 here. And that is a positive and a negative. All right. So we put them all together. And here, now we put back in our 1 over the square root of g, which is that. And here it is. So this is the curl of a vector in spherical coordinates. I think this has an interesting pattern. If you look at whatever the basis vector is, there's, as example, here's r. There's no r's in here. Here's theta. There's no thetas. Here's phi. There's no phi's. And then you see the pattern phi, phi, theta, theta, r, phi, phi. It repeats. I don't think it means anything. It's just an interesting pattern. All right, see you later.